All right, girls, so we are back to finish up our last section of Chapter 7, which is looking at quadratic functions. And so you may notice underneath, I just put in italics, graphing the function of x in the form of ax squared plus bx plus c. So this is going back to the form of the quadratic functions that we had been looking at prior to the last lesson on graphing when we're sliding the parabola left and right and up and down. So we're going to just look at how to graph it if it's in a different form. The only notation difference that you may notice is that instead of it being y equals, we're now calling it f of x. So that just means that this is a function of x versus the equation y equals ax squared plus bx plus c. So I put together a little bit of a, I guess, like hint box, cheat sheet a little bit on properties of a parabola to help us answer some questions involving these quadratic functions. So if we look at that first bullet point, a is greater than 0. So we know if that coefficient to x squared is positive, that means that this graph is going to have a minimum value. And what that means is we know that it would open upward. So the vertex there would be the minimum value of that function. And then conversely, if you have a is less than 0, that means that it is going to be opening downward and it's going to have a maximum value because you can see the vertex would be the top point there. So that is the whole reason why there's a minimum and a maximum value. The axis of symmetry, which we've talked about before, is that vertical line that runs through the vertex, but there is actually a formula that looks pretty similar to when we were completing the square. That formula is x equals negative b over 2a. And so we're going to use that to come up with our axis of symmetry when this equation is written in a different form. And then the vertex is still that point that runs, the x value is still through that axis of symmetry, and then we'll figure out what that second coordinating point is. And then finally the y-intercept is going to be equal to c, and that simply is because if I set all my values of x equal to 0, the only thing that's left is c, and that has to be my y-intercept. So we're going to run through two examples together so that you can see how to use these properties in answering these questions. So let's look at our first example. So we've got a quadratic function in standard form. We're going to consider the function f of x is equal to x squared minus 4x plus 6. The first thing we're asked to do is determine if the function has a minimum or maximum value. So to do that, we need to look at the coefficient a. Now if I look at my function, my coefficient to a is 1. So now if I recall, 1 is greater than 0, so that means that my graph is going to open upward. So my vertex is going to be located here. So that means that this function has a minimum value. Okay, now let's move on to part B. So now we need to find the axis of symmetry. So if you recall from the box above, there's a formula that we can use to find the axis of symmetry, which is right here, this x squared, or not, I'm sorry, not x squared, x equals negative b over 2a. So, oops, x equals negative b over 2a. So we're going to go ahead and evaluate that. So that's going to be equal to negative, and my b is negative 4, and my a is 1, so that's 2 times 1. So if I evaluate this, I'm going to get a negative, and a negative make a positive, so that's going to be 4 over 2, which is equal to 2. So my axis of symmetry is simply x equals 2. Then I'm going to find my vertex. Well, if I use this definition up here, the vertex is, the x-coordinate is that same point that we found, right? So the vertex I know right away is going to be 2, comma, something. Now we have to figure out what that other something is. So if I look at the definition, this says it's the function of the value that I found for 2. So all you do is you take the function, the original function, which is f of x, but we're going to, instead of using x, we're going to substitute the number 2 in for x. So this becomes now 2 squared minus 4 times 2 plus 6. And then we can go ahead and evaluate that. So that's going to be 4 minus 8 plus 6. So I'm going to use my order of operations, and I'm just going to go horizontally across. So 4 minus 8 is negative 4. Negative 4 plus 6 is positive 2. So that means that my value for y is also 2. So all I did was I took this number here and I put it in for the value of y, because remember that the function of x is also the same as y. All right, and then part D, we're asked to find the y-intercept, so that's simply the value of c. So if I look at the value of c in this, c was 6, so my y-intercept is simply the point 0, 6. Now, I've done all of this work so that I can graph, so we're going to use the information that we obtained in the previous examples. So the first thing I'm going to do is I'm going to plot my vertex. So my vertex was 2, 2, so that would be 2, 2. And then I know that this is my axis of symmetry, so I'm just going to draw a dashed line. I also have a point of my y-intercept, which is 0, 6. So that's located here. And because this is an axis of symmetry, I can use this as a mirror image. So I count 2 to the right, and then I'm going to count 2 more to the right and make my next point. And because we're just doing a quick graph of this, that's all the points that we need. And then we're going to just real quickly sketch what our parabola looks like. Okay, and then the last thing is to describe the domain and the range. So if you recall, the domain is all the x values that this function would satisfy, and the range is all the y values. So if I look at this domain, this parabola is going to continue forever right and forever left. So I can therefore say that my domain is going to be all real numbers. And then my range is the values, my y values. Well, the only y values would be starting at the vertex point and then just continuing up. So my range in this case is going to be y has to be greater than or equal to, and if I look at what value on my y-axis is a 2. So it is y is greater than or equal to 2. And that would be my domain and range. All right, so I have one more example that you can follow along with. If you want to go ahead and pause the video and see if you can complete example 2 on your own and then check your answers, and then I'll run through the explanation so that you can make sure you did it correctly. Okay, so here is example 2. So we are considering the function g of x is equal to 6 plus 6x minus 3x squared. The first thing that I'm going to do is I'm going to rewrite this in standard form just so that I don't make any mistakes in identifying what a, b, and c are. So I'm going to rewrite this as g of x is equal to negative 3x squared plus 6x plus 6. So now I can identify my a, b, and c. All right, so the first thing is to determine whether there's a minimum or maximum value. So my value for a is negative 3, which is less than 0. So that means that my graph is going to open downward, and my vertex would be located here. So that means that this has a maximum value. All right, my axis of symmetry. So I'm going to use my formula, x equals negative b over 2a, to find my axis of symmetry. So that's going to be negative 6 over 2 times negative 3. So just like in the last example, I've got 2 negatives, so that eventually that will make it a positive. So I just end up with 6 over 6, which is equal to 1. So my axis of symmetry is x equals 1. Next, I'll find the vertex. So my vertex, I know that my x value is 1, and I'm trying to find my y value. So I'm going to take my function g, and I'm going to substitute the number 1 in for x, and go ahead and evaluate. So that's negative 3 times 1 squared plus 6 times 1 plus 6. Oops, what happened there? Okay, so now let's go ahead and evaluate. So that's going to give me 1 times negative 3, that's negative 3, plus 6, plus 6. So quickly evaluate from left to right. Negative 3 plus 6 is 3, and 3 plus 6 is 9. So therefore my y value is 9. So my vertex is 1, 9. I'm going to find my y-intercept, so that's my value of c. So c is equal to 6. So therefore my y-intercept is 0, 6, just like the last example. And then now I have all this information that I can easily graph. So my vertex, I'm going to graph first, so that's 1, 9. So plot my point right there. I know my axis of symmetry is x equals 1, so I'm going to make that dashed line. My y-intercept was 0, 6, and then I'm just going to use the mirror image of this axis of symmetry and place my second point, and go ahead and sketch my parabola. And then let's describe the domain and range. So the domain in this case is still going to be all real numbers, because this arrow potentially will continue all the way to the left, and this will all go all the way to the right. So my domain is all real numbers. And my range, I'm going to look at my maximum point, which is 9. So I know that y has to be less than or equal to 9 in order to satisfy, because it's all the numbers that are below 9 that continue down this way. And that is it. So you have a practice worksheet to continue looking at the graph of these quadratic functions and using the steps that I provided. Just be sure to pop on any Google Meets if you guys have any questions. All right, I will talk to you soon. Bye.